Now that you've got multiplying and dividing real numbers that aren't fractions dialed, now we're going to move on to multiplying fractions. So when you're multiplying fractions, I've got this kind of these words at the top. So it says simplify, multiply across, simplify. There's a lot of I don't know what the right is, misunderstanding when it comes to multiplying fractions. You know, people are like, oh, I need a common denominator. I'm like, nope, that's only for adding and subtracting. Okay, well, what do I need for multiplying? I'm like, just multiply across. No cross multiply or any of that kind of words. If I could make this the word that people know, it's that when you're multiplying fractions, you multiply across. Well, the next question is, why do I have simplify at the beginning and simplify at the end? Well, the answer is that when you're multiplying fractions, you're actually allowed to simplify before you multiply or after, and I'll show you why. So let's look at an example. We've got 2/3 times 1/5. This one, I'm going to ignore the simplify first. I'm going to simply multiply across. What that means is I'm going to multiply my numerators. So 2 times 1 over my denominators, 3 times 5. And then I do it. So I've got 2 times 1 is 2 over 3 times 5 is 15. Now, just a little word, it wouldn't matter if I did 2 times 1 or 1 times 2, right? When you're multiplying numbers, it doesn't matter the order you do them with. 9 times 6, 6 times 9, right? It's all the same. And that kind of matters when we look at what we're going to look at next. But this is a great way to do it. So I multiplied across, then you always want to make sure your answer is in simplified form. So 2/5. Is there any number that divides evenly into 2 and 15? Nope. So I'm good. Well, let's move on to the next one. So let's say I did this one just simply by multiplying across. So let's call this one method 1. Okay, so I'm just going to skip the simplifying to begin with. I'm going to multiply across. When people first start doing math, this is generally the way they do it. So I'm going to go 6 times 15, right? So my numerator would be 6 times 15, and my denominator would be 5 times 8. So I'm going to look at this and go 6 times 15 is 90, and 5 times 8 is 40. Then I would have to simplify after I've multiplied. So I'd be looking for a common factor of 90 and 40, so I'm going to go for 10. 90 is 10 times 9, 40 is 10 times 4. So then I can look at that and be like, oh, well, I've got a 10 divided by 10 here, which is 1. And this is where everybody messes up. You're only allowed to do it when it's multiplication, because this is 10 times 9 divided by 10 divided by 4. So it doesn't matter whether I go 10 divided by 10 times 9 divided by 4, or if I go 10 times 9 divided by 10 divided by 4, all the same. So just know that when you're multiplying, there's a reason multiply and simplify rhyme. It's that when you're multiplying, so everything in here is multiplying, no additions, no subtractions, you can just look for common factors and divide them out to make 1. So then I know my final answer for this one is going to be 9/4. Well, method 2 is, what if I wanted to simplify first? So I've still got this 6 times 15 over 5 times 8. That's still there, but I'm going to look to see if there's any common factors before I go. In other words, 6 is 3 times 2, right? 15 is 5 times 3. On the bottom, 5 is just 5 times 1, and then 8 is 2 times 4. Okay, so I've kept this first line the same, which in other videos I haven't. I've done them very separately, like this is 2 times 3 over 5 times 1, and so on and so forth. But I wanted to show you why you're allowed to do this simplification. Okay, if you look here now, I've got 3 times 2 times 5 times 3, divided by 5, divided by 1, divided by 2, divided by 4. A lot of people are probably yelling at screaming like, but Karen, it's multiplying. I'm like, yeah, it is, but it's in a division symbol. So this is 3 times 2 times 5 times 3 divided by bracket 5 times 1 times 2 times 4 unbracket. And it's because you're actually dividing by all of those numbers. So I can literally go 5 divided by 5 is 1, 2 divided by 2 is 1, and I could say, hey, what am I left with? 3 times 3 is 9, and 1 times 4 is 4. So you can remove these common factors. Now, the way you've traditionally probably seen this done is people have gone, what goes into 6 and 8? Oh, 2, so I'm left with 3 and 4. What goes into 5 and 15? Oh, 5, so 1 and 3. And then multiply across, which is great. It's fine. It's the way I was traditionally taught as well, and when I'm being lazy, that's what I do as well. But it can get messy and kind of gross. I started doing this recently, and I'm like, ooh, it's clean, and I like it. So do what you will. Some people might still multiply across and then simplify. Some people might look for those common factors first and then simplify. This will set you up really well for chapter 6, just FYI. And then this last one I wanted to show, you know, we've got this whole number or this natural number times this fraction. But remember, whole numbers, natural numbers, integers, they're rational because 4 is 4 over 1. So this is 4 over 1 times, right? The bracket just means multiply. Sometimes I get sick of drawing brackets. 5 over 2. Now again, you can multiply across. 4 times 5 is 20, over 1 times 2 is 2, right? So 20 over 2. And then I could simplify. 20 divided by 2 is 10. Or I could go through and I could look for those common factors. So 4 is 2 times 2 over 2. So then I can cross out some of those 2's. Boom, boom. I'm left with 10 over 1, which is 10. Right, 10 over 1, which is 10. Or you could have done it right from the beginning and said 2 goes into 4 twice and into 2 once. I'm left with 10 over 1, which is 10. You know, you get to this level of math and it's a bit of a choose your own adventure. What do you see to do? How do you like showing your work? And again, like I said before, sometimes when people see this, they're like, oh, it makes sense. I've always done this, but I didn't know what I was doing. Whereas this, I'm like, okay, I'm looking for common factors. Sweet. All right, here's that special note that I actually should have put earlier in the note, but that negative x over y is the same as x over negative y, which is the same as just putting a negative out front. So let's look at these questions, and I'll do the first two with you, and then I'm going to leave the second two for you to try, but of course I'll make a video in the video. So for this one, I've got this negative 5/8. I personally would go negative 5, like I would put the negative with the numerator. It doesn't go both, it only goes one to keep the fraction negative, right? And then I'm going to simplify as I go. So I'm going to go 8 is 4 times 2, so that I can go 12 is 4 times 3, and then 13 is prime, just like 5, and then I can simplify. So I can go the 4 with the 4, and then I'm left with negative 5 times 3 is negative 15, and then 2 times 13 is 26. Or again, you could have simplified before. If you had multiplied across with this one, I'd have to use a calculator, right? So multiplying across, I would do negative 5 times 12, so negative 5 times 12 is negative 60, over 8 times 13 is 104. But now I'm left simplifying this gross thing that I don't want to do, right? It's big and it's cumbersome. I mean, I look at this as both having ending and even numbers, so I would definitely take out a 2 first. So 60 is 2 times negative 30, 104 is 2 times 52. Now I can simplify the 2's to 1. And then I'm left with negative 30 is 2 times negative 15 over 2 times 26. I can again, 2 divided by 2 is 1, and I'm left with negative 15 over 26. And again, if I was being careful all the way along, you know, this should have been 4 divided by 4 is 1, right? Anytime you take out a common factor, you're taking out factors of 1, right? Anything divided by itself. And then again, this guy, it's got integers, but it's no different than the one we did at the end of that first row. This is 2 divided by 3 times negative 6 over 1. You can simplify before you multiply, you can simplify after. So this one, maybe I'll just multiply across. 2 times negative 6 is negative 12, 3 times 1 is 3, a negative divided by a positive is a negative, 12 divided by 3 is 4, right? Choose your own adventure. I don't care how you do these. What I care about is that you're getting the right answer. And if you're wanting to check these with a calculator, fraction skills are very important, especially when we get to chapter 6. But you know, if you want to see if you're doing it right, how do you plug that in? Well, 2 over 3 is the same as 2 divided by 3 times negative 6. That gives me negative 4. How would I plug this first one in? Well, negative 5 divided by 8 times 12 divided by 3. I get this gross decimal, like negative 0.57692. But I could plug in negative 15 divided by 26 and to see if I get the same answer, right? That's how I could check to make sure that I've done it correctly. Or if you know how to use your fraction button in your calculator, great too. But just know if you rely on those things, you will get stuck in chapter 6. So try to do fractions just as fractions, right? Know your rules. So I'm going to encourage you to pause the video now and try answering both of these questions. And again, I'm a bit of an in-between. Sometimes I multiply across and then simplify. Sometimes I simplify before I multiply. It's kind of a choose my own adventure. I'm going to go negative 3 over 4 times negative 5. I'm going to see that I can pull a 3 out of there. Now notice I put the negative up with the 5. I did not also put it with the denominator, right? So I could look at this and I could go negative 3 divided by 3. I'm going to keep it as a negative 1, right? Not a 1 this time. And then I would get negative 1 times negative 5 is positive 5, and 4 times 2 is 8. Which again, if I had multiplied across, I would have got negative 3 times negative 5 is positive 15, over 4 times 6 is 24, and then I would have looked for a common factor of 3. So 3 times 5 over 3 times 8, which is going to leave me with 5/8. I do not care how you do it. 5/8. And then this one, we've got 8 over 1 times negative 1 over 6, which gives me negative 8 over 6. Now I'm going to simplify. 2 times negative 4 over 2 times 3, which leaves me with negative 4/3. And again, maybe you wouldn't show this step, right? Maybe you guys can jump straight from knowing that negative 8/6 is negative 4/3, and that's awesome, right? I'm just trying to make it accessible to all. So maybe you need to see those things, maybe you don't. So go and practice the questions for multiplying fractions.